Dear viewers, what if I told you about something completely new today? I've been developing my private smart home system for more than 10 years. Thanks to artificial intelligence, I can finally tell unbelievers that this home is indeed smart. The smart home. It would probably be best to start with a brief description of my system. But respecting the viewer's time, I will first show the scope of this video. You can then decide if there is anything here for you or not. I will be working on a mini PC with an N100 processor. This is a very good platform for home lab. It is cheap, efficient, and powerful enough for many applications. Debian Linux is installed on the mini PC. If you start from scratch, the system installation process is shown in the previous video. I will be using the Visual Studio Code editor. It's a popular choice of many programmers, so it's worth exploring even if you think VI is the best editor in the world. The mess with libraries is another name for Python, but it doesn't have to be that way. VENV is a virtual environment that structures everything beautifully. I will use it. ChatGPT serves even better for programming than Googling Stack Overflow. Therefore, I will use it to design a minor class. Especially since OpenAI recently presented the canvas, which is worth showing. The engine of my solution will be GPT-4o Mini, accessible through an API provided by OpenAI. I plan to use the playground to test my prompt. LangChain is a leader among libraries that facilitate work with large language models. I'll be boring and use their product. Or maybe it's even worth saying the LangChain ecosystem. LangSmith is a product from the same garage. Also great, so they fully deserved to the term ecosystem. And one more brilliant product at the end, Docker. Over the years of maintaining the system, I have learned that the stability of various modules and components during a variety of upgrades and migrations is very important. That's why I greatly appreciate the isolation of stable environments inside Docker containers. And it's not a tool. It's the Power Utilities website, from where AI will take information about power outages. If any of the topics or technologies are interesting to you, watch the video to the end. This is probably the moment to speak briefly about my system of smart automation. As I said, I have been developing it for more than 10 years, so before it became trendy. Smart home integrates many home systems: lights, heating, air conditioning, photovoltaic panels, gas and electricity meters, security system, entertainment, surveillance cameras, flood sensors, intercom, gate, blinds, and more. Integrated, central, while modular. In fact, these are two systems in two different localities, but working together for higher reliability. In this second location, a need emerged. Quite often, the electricity is out there and there are devices that require continuous power. Of course, the supply is backed up by a UPS, but if the outage is to be longer, then a shutdown procedure must be followed to stop the equipment, which unfortunately cannot be automated. That's why I'm committed to checking the expected time for the power utility to clear the outage. This can be checked on the website I have already shown. The site doesn't have an ideal structure, because outages vary in scope: towns, neighborhoods, or individual streets. This is an ideal case for AI. In this episode, I will prepare a program that will prepare a one-sentence message to send to users of the smart home system. Enough talking, it's time to get to work. First, I'll log on to my mini PC. I use PuTTY to connect to Linux. I'm logging to my account. At first, I will show that the server actually has N100 processor with 4 cores. I love this platform for its energy efficiency and capabilities. But let's deal with the important things. First, the Python version, 3.11. The Python PIP package manager is installed, version 23. I also need a virtual environment. VNV is also installed. It is a Python module. I need to create a directory for my project. AI Power is a nice name, isn't it? Now, virtual environment creation. I'm using the same name. Created. Script for activation is in bin directory inside of my project folder. Virtual environment has been activated. Its name in brackets is an indicator that I'm using the environment. Any Python library I install from now on will be available in this environment. Physically, it will be installed in subdirectories of my project directory. I plan to use .env to store my variables like API keys. I can install this with pip. It's been installed. This is a fresh environment, so this should be the only package installed. I confirm it by pip freeze. I'll need also a beautiful soup. SoupSieve is installed for dependencies, so I should have 3 modules. Yes, that's right, there are 3. The base of my project environment is therefore complete. From now on, my main tool will be Visual Studio Code. It's a great editor for developers, which will also allow me to connect to my Linux and work directly on its files. I'll show you how to configure it right away. I started Visual Studio Code. I go to Extensions to show you that I have Remote SSH installed. This is what allows me to connect easily to Linux. I need to click the small icon in the lower left corner of the window. Now, the Connect to Host option at the top of the screen appeared. On the right side, I see that it comes from the Remote SSH add-on. Now I need to enter or choose my host. A new window with the connection appeared. I need to enter my Linux password. Connection is in progress, and I'm connected, so I can open my project folder. AI Power. I'm asked again for my password. Now I need to confirm that I trust files in this folder. Now, I am ready to create the first file. .env is a special file that stores operating system environment variables. This is a popular way to store API keys and various global settings. For now, I'll just place here the API key from OpenAI. Since the keys are secret, I will do this in a second session. What matters to you is the name of the variable that stores the key. OpenAI _ API _ key. Ctrl+S to save the file. It's time to create the main file of my project. aipower.py. The file has been created. Let me check the setup by writing a chunk of code. I will initialize the environment variables from the .env file. First, I need to import the .env library, or more specifically, load.env function. In addition, OS would be needed. To initiate variables, I use the function load.env. That's it. No warnings in editor. Libraries are known. A nice feature of the Visual Studio Code editor is direct access to the terminal. Since I work with SSH, it is, of course, my Linux terminal. What's more, thanks to one of extensions, my virtual environment has been activated automatically. Very nice. I can even move the cursor over the function call and see brief documentation and, most importantly, how to call it. But let me do something more for my dearest viewers. I'll enlarge the font a bit so you can see better the code and terminal, especially since some people watch video on their smartphones. Since I want to extract data from the website, I need a WebScraper. I'll let GPT write it, especially since they recently introduced Canvas, a cool feature for working with prompts related to code. It's worth showing, because maybe not everyone knows it yet. I wanted to use Beautiful Soup, because I have already installed it, although it's a pretty obvious choice. Let's see what will be produced. It's switched to Canvas, promoting the code to the main part of the screen. The class uses request and the Beautiful Soup as expected. It contains 2 methods, fetch content and get content. An example call is at the end. Let's play with the code and ask GPT to simplify this to one method. Look at this! This is a breath of fresh air in the chat interface, isn't it? Let me copy Power Utility website URL to show something more. I can refer to a specific passage of code and ask for a change. I'll request changing sample URL and removing the name condition. Huh. I wasn't entirely precise, but I can quickly correct it by myself. I can edit the code. Another great feature, right? One more thing. I will make sure that the content of the page will not contain unnecessary elements like scripts or formatting. I'm interested in clean text and nothing else. Even as GPT would manage to analyze a complex document. After all, the number of consumed tokens also counts. Since this is just a piece of code, not the most important part of our project, I won't focus on it too much. It is supposed to be primarily usable in our example, so I will copy it and move it to Visual Studio Code to test if it works. Paste it as a new file. I need to name it. WebScraper.py. Not a very extravagant name, but clear. It looks okay, I can run it. No module named requests. Yes, I imported this but not installed, so I'm using pip to do this. Installed successfully, so I can run it again. Success. I see text from the website. The text is in Polish, because that's what the original page is, but it won't be a problem for AI. However, the clarity of the text is poor. The line divisions seem to be missing. I'll ask GPT for a fix. Or I will simply report that there is such a problem, and see what it does. This was quick. The new version copied. Pasted. And executed. This time is much better. The text is logically divided and fully readable. I'll copy this part to include it in my main program. Now I can remove the whole part of the code responsible for testing. It is not needed anymore. I have pasted the code and now I am correcting the indentation. Done. However, to use this code, I need to import the class. The file is called WebScraper.py, and the class is named Simple WebScraper. I'm adding a line to print the content returned by the scraper, and I can test the program. It returns the same content and everything is correct so far. So I can take care of the installation of LangChain, which I will use right away. This will take a moment, so it might be worth telling you about the library itself. LangChain is a great tool that helps to use large language models easily. It lets you connect LLMs with external data sources, APIs, and other useful tools. This allows you to build things like chatbots or knowledge-based apps. LangChain is popular because it makes working with language models faster and more flexible without a lot of code. I will be using LangChain to connect to OpenAI, specifically to GPT-4o Mini. Therefore, I also installed a package to work with OpenAI. Let's use it. I'm starting with an import. From LangChain OpenAI, import chat OpenAI. Now I can define a model using the chat OpenAI class constructor. The temperature determines the degree of the randomization, or otherwise the imagination of the model. I set it low to prevent hallucinations and have very consistent responses. As I told before, I want to use GPT-4o Mini, because it is cheap and sufficient for this case. The model is fine, but I will define a parser, which will be at the end of my chain, the most standard one. As you can see, the string output parser hasn't been recognized. This is because I didn't import it. I will do it. From LangChain core, output parsers. Import string output parser. Now this is fine and I can use the parser. But before moving forward with my main task, I would like to test if the code works. Believe it or not, but it doesn't take much more than that to have a simple application. First, I define the chain using the LangChain expression language. It contains only two elements, a model and a parser. I comment out the output of the content by the scraper, because in this case I won't use the scraper at all. What I want to output is GPT's response to my greeting. Technically, I just have to call the invoke function on the defined chain. And that's it. I can try to run the application. AI has just responded. It wants to know how it can assist me. And that's the beauty of LangChain. A few lines of code are enough to communicate with AI, and more complex things are done just as easily. Don't believe it? Let's expand the example a bit by using a template, because in the final version of the program, I will need it. This time I'll start with the imports. I will need 3 things. From LangChain core prompts, I will take the chat prompt template. Even if my application is not a chat, it will be useful. While for my templates, I will also need messages. Specifically human and system messages. You may ask, why to use templates? It's simple. They allow you to organize repetitive prompts with variable fragments. I'm defining a system message. The system message allows you to communicate the initial guidelines for AI. For now, it will be whatever. The name in brackets is the aforementioned variable part. While the systemplate is just a string, the prompt template is already a proper template. One way to create a template is to use messages. I remind you that I have imported system message and human message. The system message will be defined somehow. I will change it in a moment. And the user message will simply be a variable. I will substitute the content of the website in this place. For now, I'll ask you to say hello to the user, just for a test, to check if the template works. Now my chain is a little bit more complex. It contains 3 elements: template, model, and output parser. And once again we come to the advantages of LangChain and the simplicity of its use. Calling a request for a chain is almost no different from the previous case. Maybe with the minor change in invoke method call. We pass a dictionary that is responsible for substitutions. In this case, the text from the user message turns into a subdalf greeting. And that's it. Program is ready. I can run it. As you can see, we got the answer without a problem. That is, our test development works as designed. Now it's time to focus on the relevant prompt for our main application. The easiest way to do this will be to leave Visual Studio Code for a while and go to the proper tool. The OpenAI platform offers the Playground. This is a utility that allows you to experiment with the API in a chat-like manner. Here you can test prompts and conversations using different models and parameters. So we have full control over the model, just like with the API. So I will prepare a prompt starting with a system message. The preparation of prompts is what makes AI application development most different from classical programming. We explain to the LLM how to perform a task using human language, and sometimes we are well understood and get the right result, and sometimes not. A lot depends on the model, but a fair amount also relies on our ability to clearly communicate our needs, and on the knowledge of various techniques. Because prompt engineering is not only the ability to express ourselves clearly, but the two have a lot in common. At the beginning of my prompt, I give the necessary context and define the role of the assistant. It will be analyzing documents in Polish, although I expect results in English. It will only look for information about a specific street. The template mechanism will allow me to make this more universal in LangChain later. Then I specify very precisely what 3 pieces of information I expect in the result. At the end, I give examples of the expected answers. This helps a lot to format the output properly. However, for the test, I am still missing one more thing: the document. So I need to go back to my program for a moment and modify it a bit to show the web content again. In order to make the test valid, it has to be the content from the WebScraper, because it is the one that will be delivered in the final application. Okay, the content has been returned. I have to mark it in the terminal, although it is quite a long file. Of course, I could also rewrite WebScraper to get rid of unnecessary headers, footers, and menus. But that is first of all a quick proof of concept. Secondly, it's supposed to be a fairly versatile program and handle other tasks in the future. Third, it is supposed to continue to work after the site structure is changed. I'm pasting the document as a user message, because this is my plan. One more thing. Let me see one example of a power outage. This is a planned shutdown in Gdansk at Kielnienska Street, from 8 in the morning until 1 p.m. I now need to correct the system prompt to ask for this exact location. The city's okay, only the street differs. Before I invoke the prompt, I will try to find the information in the document. Here it is. So the scraping was successful. Let's run this and see a result. It has been finished. I need to scroll down to see the response. Perfect! The information is absolutely correct and precisely matches the pattern I have provided in the sample answers. Okay, let's go back to the Power Utility website. I'll turn off the translation of the page so you can see that the original version is in Polish and GPT has no problem with it. It is also worth extending the test so that it is no longer based on the simplest example first on the list. Let's look for something more difficult, not just to pronounce, but to find. Chef Region, Pszczółki Municipality, Skowarcz City, Stokrotki Street. A perfect candidate for the second test. I need to change the system prompt. For now, I change it manually, but in the application it will be based on the template. Although in reality I will only be checking 2 cities. After all, I have a house in a fixed location. I just don't consider hard-coding names a good practice. This response I need to delete to avoid confusion and repeat the test. And this one I'll delete and paste again. Let's run it and see the response. Perfect. This is also correct. The last test to be performed remained a negative case. I will prompt for an outage where it is not listed. The beautiful city of Torun and its main street. I'm launching and hoping for no information. Exactly. There is no outage. All tests passed. The prompt can be brought to the program. I'm selecting this and copying to the clipboard. I paste this in the system template space as a multi-line. I will enable line wrapping for better readability. Since this is a template, the logical move is to change the city and street to variables. As I said, we avoid hard-coding the data. This is a very good practice. The next modification is to disable printing the contents of the document. I no longer need it in the terminal, only in the prompt. So I substitute the contents of the document into the template in place of the user prompt, just like I did in the playground. It remains to uncomment the invoke call on chain. Of course, the template has changed, so text must be replaced by city and street. And finally, I can run it. It works. There is a planned outage in Reda between 11 a.m. and 2 p.m. Let's confirm this on the Power Utility website. Here it is. Town of Reda, Kazimierska Street, and the planned outage between 11 a.m. and 2 p.m. So, our main functionality still works without any problems. On the other hand, using the city and street name directly in the code is still rather inelegant, even as we use the template. Therefore, I would like to quickly move the acquisition of this data to the parameters of the program call. I imported argparse. Now I'm defining a new argument parser. I expect 2 variables passed to my program, city and street. It is not complicated, but it's very convenient, so it's worth solving it this way. Parser has been defined. Now assignment of arguments. The last remaining part is replacement of the hard-coded values to the parsed arguments. Now I can run the program, but I will do it manually, because it is necessary to provide arguments. Very good. Correct answer. And actually, we could stop here and say that this is a ready-made module for smart home system integration. But this is an educational video, so I will demonstrate how to debug queries to LLM using LangSmith. Then I'll make this program a ready-to-use Docker container, and at the end I will say a few words about integration with home automation system. LangSmith is based on a software-as-a-service model. It does not require installation, only creating an account on their site. It is a paid service, but you get a developer account up to 5,000 traces per month for free. Let's create a new project. As you can see, I won't even have to install new modules, because everything is built into LangChain. I enter the project name. It remains for me to copy the 4 environment variables that need to be added to my program. Of course, I also need to insert the API key generated on this page. But the keys are secret, so I'll do it behind the scene. I pasted everything together into the secret.env file. Now I will execute the program again to collect traces. I don't have to do anything else. I can directly go to the LangSmith website and see if my project appeared on the list. Yes, it is here with one run. I find out that in this one run, I used less than 2,500 tokens with the cost rounded to 0. When I click on my sequence, I can see the details. I have general information here, including the result and the dictionary with parameters used to invoke the chain. I can check the whole conversation. I also see the actual cost. Obviously, these are very simple requests, so I could easily handle it without such a tool. However, for more complex cases, LangSmith is priceless in a variety of analyses. It makes it easy to see exactly what is being asked, what docs the various LangChain functions provide, and what the results are, and of course, what the costs are related to it. Okay, the last big point in my plan is to wrap this program in a Docker container. As I said, this gives me more comfort of independence from system updates or ease of migrations. I'll establish an SSH session to my mini PC so you can see all the actions clearly. The container must comprise all the necessary Python libraries. So to start, I activate my venv environment to save the list of requirements. The pip freeze command is used for this. As you can see, the list is quite long. I will redirect it to the requirements.txt file. I also need to decide what will be the foundation for my container. I will base it on the official Python container Slim version, specifically Python 3.11 Slim. You can easily find it on Docker Hub. As you can see, this is the official image, which in the other hand is based on the official Slim Debian image. Creating a Docker image is very simple. It is based on a Docker file that contains the configuration and instructions required to create the image. The easiest way to explain it is with an example. So I create a Docker file for my program. I specify what image is the source for me. As I said Python Slim, I set the environment variable responsible for disabling cache generation for bytecode. The other variable disables buffering. I'm setting work directory to /app. The requirements.txt file contains the necessary packages. I copy it from the current directory to the work directory. Now, inside the prepared image, I run 2 pip commands. One to update pip, the other to install the required packages from the file listing them. My Python program is not yet in the image. I copy all the files from the current location to the image, and there is only one step left, which is to determine the entry point of the image. Docker file is ready. I can save it. The command to build the image is docker build -t, the name of the image, and at the end, the work directory. Endpoint? Entry point. Yes, here is the mistake. Let's restart generation. This is pulling required images. Another error. It seems that pip update failed. Let's see the Docker file. There's a mistake somewhere here. At the upgrade. Sure. I forgot to add that I want to upgrade the PIP package. One more time. Perfect, now it's better. This is just a warning. I'm not planning using venv inside this image. Package's installation is in progress. Awesome! After much trouble, the Docker image built correctly. I can now get on with running it. During the first run, I assign a friendly name to the container using the name parameter. It can be the same as the name of the image. It returned error, because I didn't specify city and street. Let's correct this. I'll find some outage on the power company's website to make a final test of the correctness of operation. I need a city and a street. I'll use this again. Reda Kazimierska Street. Let's enter this. And of course, full success. So we have a complete container that can be easily moved between servers with the same architecture. It provides us a clear, short message about the power outage at the selected location. This is exactly what we wanted. Obviously, this is only a very tiny part of the whole smart home system, but that was my plan. I wanted to cover here only those elements that are related to AI. Although, of course, I'm open to suggestions, and I'd love to read your comments. And if you would like to ask how I deliver this message to stakeholders, the answer is simple: by email and push notifications to the phone. Needless to say, sending an email from Python is easy. Enough to say that GPT delivers you the right class in seconds. Trivial, right? Well, yes, but you can ask when I send this message. 5 minutes after the power goes out. How do I know about the power outage and how do I transmit this information to the container? Very simply. My system allows integration using the MQTT protocol, as, by the way, do very many automation systems. So what prevents you from requesting a program that waits for the appropriate MQTT message? If it receives it, it starts my container and sends what is returned by email. AI makes life easier, at least today. We'll see if it's the same tomorrow. I hope I didn't bore you today. It was supposed to be simple, educational, diverse, so as to show some tools with a practical example. If in your opinion this is a useless module, I understand. In my case, it was necessary and works great. On the other hand, the most important thing is that you can build your solutions in a simple way. And here, the LangChain library, as well as the other tools, are absolutely essential. It is worth learning it. Let me know in the comments if you would like to see anything else from this topic. Maybe from combining surveillance with AI that analyzes images, Google Coral, Frigate, Vision AI. There are many possibilities, although I haven't yet thought about what I want and can show. For now, give a like and subscribe to the channel to encourage me. Let AI work for you, not against you. See you next time.